When you delete a file, is it actually gone? Not really, because your disk doesn't store files the way you think it does. Let me show you what's actually happening behind the scenes. Most people think files are stored as one continuous block, but in reality, your disk breaks everything into smaller chunks. To understand this, we need to go step by step, from the smallest unit to how files are actually stored. The smallest unit a computer can address is a byte, 8 bits. But disk doesn't read or write 1 byte at a time. They operate in units called sectors. Traditionally, a sector is 512 bytes. Modern disks use 4096 bytes. Now again, disks don't usually allocate space one sector at a time. Instead, they group multiple sectors into something called a cluster. For example, 8 sectors of 512 bytes each is equal to one cluster of 4096 byte. To summarize it again, 512 bytes combined create a sector, and 8 sectors combined create a cluster. And a cluster is the smallest amount of space a file can occupy on disk. This is the key point. Let's say you have a file of 1 KB, which is 1024 bytes. As we discussed, a cluster is of 4 KB, 4096 bytes. Now, even though your file is 1 KB, it still takes 4 KB on disk. The remaining space doesn't just disappear. That unused space inside the cluster is called slack space. Slack space is unused space inside an allocated cluster. Why it matters? This space can contain leftover data from previously deleted files or even hidden malicious data. Now let's take a file of 5 KB. This one needs 2 clusters of 8 KB. So the first cluster gets filled up completely and we have some space left in the second cluster. That remaining space in the second cluster is again slack space. So here's something interesting. When you check file size in Windows, you are seeing the logical size, not the actual space used on disk. In this case, the logical size is 5 KB, but a 5 KB file might actually take 8 KB on disk because storage is based on cluster, not exact file size. Now you understand how data is actually stored on disk and why even empty space can contain valuable evidence. Like, share and subscribe if you are learning digital forensics. I am breaking down everything step by step. I'll see you in the next one. Keep defending.